Hello everyone, welcome to Anonymous World. Hope you all are doing well. So today is day 6 of February 2023. So let's get started. So it's day 6, memory corruption, memories of Christmas past. So throughout the merger, we've detected some worrying coding practices from the South Pole elves. To ensure their code is up to our standards, some frostlings from the South Pole will undergo a quick training session about memory corruption vulnerabilities. And all courtesy of the Team B. So learning objectives, understanding how a specific languages may not handle memory safely, understanding how variables might overflow into adjacent memory and corrupt it, and at last exploit a simple buffer overflow to directly change memory we are not supposed to access. So connecting to the machine, we do not need to start the attack box today. There is a direct link available. So here our link will come. If you receive a 502 error, please give the machine a couple of more minutes to boot and refresh the page. Okay, so there is a game, I think. So in this game, we'll play as cat or mouse. Our objective is to save Christmas by buying the star for our Christmas tree from Van Frosty. And in addition to the star, we can buy as many ornaments as we can carry to decorate our tree. So to gain more money to buy things, we can use the computer to do the online freelance programming jobs. We can also speak to Van Holly to change our name for a fee of 1 coin per character. And he says that this is totally not a scam. He will actually start calling us by our new name. He is after all into identity management. Okay, so there are coins in this game, and with 1 coin we can change our name too. So is this a bug? Before the training event starts, Van Jolly approaches Honeybell and says that they have been observing some weird behaviors while playing the game. They think the ghost of Christmas past is haunting it, and Honeybell asks him to reproduce what they saw, and Van Jolly boots up the game and does the following, which we are free to replicate. So let's see, our machine must have loaded. Okay, so tree builder 2023, press escape to continue. So controls are given. We can use arrow to move, backspace to reset inventory, tap for debugging panel, and space to interact or speak. Okay, what else is there? And press space to continue. Okay. Okay, so the game, to finish the game, all we need to do is get a star to put up on our Christmas tree. And after you get the star, just interact with the Christmas tree, and that's it. You are free to buy as many as additional ornaments as you can carry to customize your tree. Okay, so this is our character, and this is the Christmas tree, I guess. Now let's see the description. So use the computer until you get 13 coins. Ask Van Hoy to change your name to Scroogerox exclamation mark. And suddenly we have 33 coins out of nowhere. Van Jolie explained that when you change your name to anything large enough, the game goes nuts, and sometimes you will get random items in your inventory, or your coins just disappear. Even the dialogues can stop working and show random gibberish. So Honeywell doesn't look convinced. After some thinking, she seems to know what this is all about. So let's try to interact with the game. There is something in our inventory, and we have 1 coin. So this is the Xmas tree. You still don't have a star. Get one and talk to me. Okay, talk to this guy. So this is Van Holly. Howdy cat or mouse. I can change your name for 1 coin per character. Okay, sounds like fun. Let's do it. Let's enter a new name. So it was okay. So for 1 coin, only one character will be changed. There you go. Enjoy your new game. So you can see our name is been changed to S instead of cat or mouse. So thanks. How do you even change names? I work in identity management. Okay. See what else we have. Okay, we got 1 coin. We got one more. So we need to play with this computer to get more and more coins. So in the description it was written we need to get 13 coins. So let's get that. 8. So just keep hitting space and you will get +1 coins every time. 11, 12, 13. Okay. Now we can change our name again. Okay. So there you go. Enjoy your new name. So you can see now we have 33 coins out of nowhere. Let's see what's the issue. So remember that whenever we execute a program, and this game included, all the data will process somehow through the computer's RAM. And in this video game, our coin count, inventory, position, movement, speed, and direction all are stored somewhere in the memory and updated as the game goes on. So this is the game's memory, and everything is stored here, like coins and your position and inventory. So usually each variable stored in memory can only be manipulated in specific ways as the developers intended. So for understanding, you should only be able to modify your coins by working on the PC or by spending money either in the store or by changing your name. So these are the only three ways you can modify your money. And in a well-programmed game, you shouldn't be able to influence your coins in any other way. Okay. So what happens if you can indirectly change the contents of the memory space that holds the coin count? And what if the game had flaw that allow us to do unintended things like overwriting pieces of memory which we are not supposed to do? So this is where memory corruption vulnerabilities comes, and this only allows us to do that and much more. So according to Honeywell, we will be needing a debugger to check the memory contents while the game runs. And on hearing that, Sprinkle say that they programmed a debug panel into the game that does the exactly that. So accessing the debug panel, we can use a tab button to open the debugging panel. So this is the debugging panel. So there are two modes in debugging interface. One is ASCII view and other one is the hex view. So ASCII view memory content will be shown in ASCII encoding. It is useful while trying to read data. And hex view, this is useful for case where the data you are trying to monitor is a raw number or other data that can't be represented as ASCII. So just press one more time tab and you will see the hex encoding. Okay, let's go ahead. Investigating the Screwbrick Rock case. So now we have debugging panel. Let's start doing that. So Honeywell wants us to focus our attention on coins variable. So go to the computer and generate a coin. As expected, you see the coin count increase in the user interface and the debug panel simultaneously. Let's see. Let's go to this table. Yes, you can see coins value is changing. So now PC is broken. Okay, our coins changed to 34. Right now. So then Hannibal points out that right before the coins memory so we have the player name variable. She also notes that player name variable has only rooms to accommodate 12 bytes of information. You can see 444. We can only store 12 bytes of information in the player name. But why does it matter at all? Asked the confused man Twinkle. Because if you try to change your name to Scroogy Rocks, you would be using 13 characters, which amount to 13 bytes. So of course it will overflow that player name variable. And it will overflow to first byte of this coin. So before changing the coins to 34, there was one exclamation mark, which came from this one, Scrooby Rock's last character. So to prove this point, Honeywell proposes replicating the same experiment, but this time we will get 13 coins and change our name to this A B B C C C X. Okay, okay, let's do that. Okay, let's change our name. hit enter. So you can see the last letter of our name X is coming here in the first variable of first byte of the coin, which means it is getting overflowed, and our name is also changed here. So meanwhile, we'll keep our eyes on a debug panel. Let's try this on our game and see what happens. All of a sudden, we have 120 coins. You can see we have 120 coins. And if you see the hex value, it is 78. So what's hex 78 in decimal value? It's 120. So you can calculate that using an online tool. What was that tool? Okay, let me just open that. So you can see 78 is 120 in decimal. That's why we have 120 coins, because 78 is written here and rest are null bytes. Now let's go ahead. The x at the end of new one is split over into the coins variable. Okay, we just saw that. And as you can see, Hannibal's prediction were correct. The game doesn't check if the player name variable has enough space to store the new name. It just overflow the to next variables. Now, strings in more detail. So now by now the frostlings look baffled. It never occurred to them that they should check the size of variable before writing to it. Twinkle has another question. When the game started, the main character's name was cat or mouse, which only uses 10 characters. Okay. So how does the game know the length of a string if no boundary checks are performed? So to explain this, Hannibal asks us to do the following. Restart the game, get at least 3 coins, and change your name to Elf. Okay, let's do that. Let's restart the game. How to do that? Okay, let's just reload this. Yeah. So first, we should take 3 coins. Let's open our tab. So for now, our name is cat or mouse. Let's change this to Elf. Now let's see. So as a result, your memory layout should look like this. Okay, this is exactly this here. So when strings are written to memory, each character is written in order to taking one byte each. And a null character represented in our game by a red zero is also concatenated at the end of string, which has the simple value of 00. Okay, when reading a variable as a string, the game will stop at the first null character it finds, and this only allows programmers to store smaller string into variables with larger capacity. Okay, so to better explain this, Honeywell proposes a second experiment on strings. So she says to get 16 coins and rename our flips to a 16 characters name. Okay, so let's try that. First, we need to get 16 name, 16 coins. Okay, so now we have 16 coins. So let's change our name. Okay, so this is a 16 character name. So now you can see the null character is being overflowed to the shopk name variable. Notice how the game adds a null character after your 16 bytes. So which overrides the shopkey name variable, and if you talk to the shopkeeper, you should see his name empty. So let's check that. So which one is shopkeeper? Open our hex tab. We have 5F 64 64 64. it is 16000418, and definitely they both are not same. So how does it happen? So Honeywell explains that integers in C++ are stored in very particular way in memory. First, integers have a fixed memory space of 4 bytes as seen in the debug panel. Secondly, an integers bytes are stored in reverse order in most desktop machines. Okay, so an example is given here. So if you take your current coin quant of 119, so which is given here, and convert that number to hex, you will obtain this. Okay, so let's try that. So our current coin number is 168 4300 895. 168 4800 895. Convert. So it's 64 60 057F. Okay, so corresponding to what's shown by the debug panel, but backwards. So how many coins would you have if the hex value of the coin variable was showing the memory as follows? Input your answer at the end of the task. Okay. Now winning the game. So Honeywell is about to wrap up the lesson and call it a day, but first she explained how an attacker could now override any value to the coin variables and have enough to buy the star and finish the game. On hearing this, Grady starts laughing maniacally and tells Hannibal they rigged the game so nobody could win. And Hannibal is more than welcome to try to purchase the star. Okay, so Hannibal did some quick calculation and concludes she would be able to get enough coins. So she looks at us, at you, and asks you to show how the vulnerability can be exploited. Now heading to the question, if the coin variable had the in-memory value in the image below, how many coins would you have in the game? So it's 4F, 4F, 50, 53. So let's do that. 4F, 4F. So now why reverse? Because it is in Little Indian architecture. So it needs to be reversed. Let's see if this is the correct one. Yeah, it's definitely correct. Okay, so what is the value of the final flag? So for that we need to buy that Christmas tree. So let's go to the inventory. So red ball, green ball. So this is the star. Its value is D. So let's press D and check if we can buy that. Hey, you are not supposed to have that kind of money. Okay. I earned each coin fair and squarish. Now give me my star. The game is supposed to be invincible, you know. Here I will cut you a deal. I will give you a much cooler item for the same price. Okay, so it gave us something. I don't know what it is. Looks like sticker, logo of something Antarctic crafts. So now it doesn't allow us to buy that star. What we can do? Let's try buying that again. Try D again. Okay. Again, it's saying we can't have that amount of money, so it gave us the sticker again. What if we buy everything? No, but I don't think it has some of sold out. Let's try buying something else. Okay, it is allowing to buy everything else. Let's see. We have more than enough coins that I know. Okay, checking the variable of inventory item. So it's 11EE5 and the star null 1, 2, 3, 4. So there are it is of 16 bytes as 16 bytes, and we also have a space of 16 items in our inventory, and it's 11EE5. Okay, let's go to inventory again. It starts from ID1 and it's until ID D, so it doesn't have IDE, but it's still Antarctic Crafts logo is I think IDE, and we have this red ball at the first two place, which is ID1. Okay, and then we bought this skiddy for $120, and for that ID was 5, and here also the ID is 5. So which means that whatever we buy in inventory, so their ID is being reflected in each bytes. So for example, now it is null if we try to buy let's say this ID number 4. So after 4, it must this null byte must change to 4. So you can see it changed to 4. Okay. So let's try one thing. Let's try if we can override this particular value, the null value, to the any ID of inventory, and check if it uh, gets bought automatically. So for that we need to change our name. So let's see how many bytes are required to reach here, or characters. So there are 12. Then 2, 3, 4, 5, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 48, 49, 50. So this is the 51st byte. So let's change our name, and at the 51st character we will give any ID of inventory. From inventory, let's say we will give 2. Okay, so let's change our name. Okay, so these are 50 characters. Now let's give 2 here and press enter. So you can see something, a new item has been added to our inventory, which is ID number 2. So let's check ID number 2. Okay, what's the issue? Is that a Yeti token? I am afraid it's a fake one. The original one glows blue. Maybe I could sell it to you for the price instead. I don't know what's happening. It is not working now. Okay, you can see the ID2 was green ball, and it got automatically bought. So what we need to do is we need to get this ID at this, at any column, sorry, at any byte, and then, and like that the star will be bought automatically. So let's do that. Okay, so star is at game 12, 13, 14, 60th position. So the 60th character we need to give is D. So let's try that. Okay, then D. Let's hit enter. So you can see the star is here at the, in our inventory. We have successfully bought that. Now let's go to the Christmas tree. Yeah, so we did it. The star is there at the top, and the rest of the tree is decorated with fake Yeti coins, I guess. Let's see, you got the star. Thanks for getting me ready for Christmas here. Here's your flag. So this is the flag. My honey bell is the real star. Is the real star. Yeah, so that was the correct flag. So we have only explored the surface of buffer overflow in this task, and buffer overflows are the basis of many public exploits and can even be used to gain complete control of the machine. So if you want to learn more about buffer overflow and explore more about this subject in more depth, you can definitely check out the buffer overflows room present here. And Van Jolie still thinks the ghost of Christmas past is in the game. She has seen it where she has seen it with her own eyes, and she thinks the ghost is hiding in a glitch. Whatever that means, what could she have seen? So we will see that in next upcoming rooms. So that's it for day 6. I will see you tomorrow in day 7. Till then, keep